So here we're given this function that shows the height above the ground of a passenger on a Ferris wheel. So I'm going to actually, you can graph this to get a sense of what this function would look like. And I think it's good to also know qualitatively how this would perform. So for example, when t is equal to 0, cosine of that 0 would be 1. In that case, the initial height would be 64 minus 46. It's 18. And then as the cosine function, as t goes up, it's going to go through a maxima and then come down. So what they're looking for is how many minutes is the passenger at least 100 feet above the ground. So 100 feet, let's say, is at this point. So we want to look at this time frame that it's above 100 feet. Now, the maximum height would be when that's equal to cosine pi over 5t is equal to minus 1. In that case, the height would be 110. So that's the maximum height that happens here. And that's going to happen at the time when pi, the cosine, this angle is going to be equal to pi. So that would happen at t equal to 5. So right here in the middle. So it's a symmetric function. Now we need to find this point here. What we can do is to equate this to 100 and solve for the value of t. So this is going to give us minus 36 over 46 cosine pi t over 5. I'm going to compute this. Just make sure you keep everything in radians. So 36 divided by 46, that's minus 0.7826. Do the cosine inverse of that. Make sure you have it as a minus. So cosine, that's 2.469 equal to pi t over 5. So t would be 2.469 times 5 divided by pi. So I get 3.93. So this point is 3.93. Now this function is symmetric, which means that this distance between the midpoint and the point at which it reaches the height of 100 feet, this is 1.07. That's the difference between 5 and that. It's going to happen the same distance on the other side, another 1.07, where it's going down the height. So the total time would be twice that number. So 2 times 1.07, which is 2.14 minutes. And that's the answer.